So look at this photo, just one small area of the sun, and you can see the sunspots, these dark regions. The darker part is called umbra, the edge is called penumbra, and some of these sunspots can actually be very large, say twice the diameter of the Earth. And here you see these granulae that I've mentioned before, the so-called granulation of the sun's surface, and which is a direct consequence of these convection currents underneath that make the surface look like as if it is bubbling. And people have tracked the number of sunspots since the time Galileo pointed his telescope to the sky for the first time, since 1609. Astronomers have watched the sun, and what is observed is that the number of sunspots varies over time in a periodic way. It goes from maxima, and there are a few hundred sunspots at the maximum, and then comes down to very few spots, then goes up again, comes down, up, down. And on average, the spacing between two successive maxima is 11 years. And so is the spacing between two successive minima, 11 years, okay? It's not precisely 11 years, but close to. And right now, we are near one of those solar maxima, somewhere here. Now, the sun is very active. There was a period from 1645 to 1715 where there were virtually no sunspots. And this period of very few sunspots is called Maunder minimum. And it coincides with a mini ice age that existed at that time in Northern Europe and North America. The temperature plummeted, right? So much so that the Northern Sea froze, many rivers in Europe froze, including River Thames, which is unheard of. There are actually paintings of people skating on the frozen Thames at that time, right? So clearly there is some connection between the average temperature on the Earth and the solar activity as measured by the sunspots. When the sun is not very active, as exemplified by a few sunspots that exist at the time, the temperature on the Earth seemed to drop. And indeed, that correlation exists over a period of time. So here is the Maunder minimum. What is plotted here is on the left, it's the number of sunspots, right, versus time. This horizontal line denotes essentially sort of what is considered to be normal winter as expressed by the average temperature on the Earth. So above this line we would have warmer winters, and below we would have colder winters. And this is the average temperature of the oceans over time. And you can see that it roughly tracks the maximum in these peaks, right? I could do this. Right? So there is definite correlation between the average temperature on the Earth and the solar activity as given by the number of sunspots. Maunder minimum, named after an astronomer who noticed that, it's a period from 1645 to 1715 of very few sunspots.